Hello everyone. This is Unit 1, Day 10. Ignore what it says at the top. This is Day 10. Okay, so now we're going to be solving rational equations. Okay, so right here I have listed some steps for you. I strongly encourage you to jot them down. Okay, so here is kind of a basic scenario for how it is that we solve these rational equations. And I'm going to show you two different methods, and I'm going to leave it to you to decide which one you prefer. Okay, both of them get to the same answer, and so I'll demonstrate both in order that so you guys know what I'm talking about. Okay, so the goal here is to solve for the variable by getting rid of the fractions. Okay, so again, there are two methods you may use. I will demonstrate both. So method one we call the fraction buster. Okay, so it's when you factor all denominators, you find the common denominator and give it superhero powers. We're going to call that the fraction buster. Multiply the fraction buster to all numerators to cancel the denominators, and then solve the equation that remains. Okay, and so you guys will see what I mean when I try that on example 1. Another method, okay, I'm just going to call it the denominator drop. Okay, so what happens is you start by factoring all denominators. So both methods have a few things in common, but in this case we find the common denominator for all terms on both sides of the equal sign. Once every denominator has been set equal to each other, we drop the denominator and then we solve, okay, the equation that remains. All right, so let's get down below here. So we look at example 1, and I'm going to do method 1 here. Okay, so I'll write it right there so you guys know which method I am using. All right, and so method 1, what happens here, okay, is we're going to come up with a common denominator for both of these terms, or all three actually, right? Except in this case we have a 1 to the right, so this one's rather simple as far as finding a common denominator for this side, okay? But on the left side of the equal sign, okay, the only common denominator we'll be able to use is just by multiplying those two expressions, okay? So, our common denominator is y times y plus 1. Now, before what we were doing is we were just adding expressions, right? So, or subtracting, adding and subtracting expressions. So what we had to do here, right, is when we were setting these things up, okay, we would, okay, multiply what we were missing over here. So we'd multiply this by y. We'd have y plus 1 on this side, okay? And then on this side, we'd multiply by y plus 1. And then again, we'd have y plus 1. All right? We're going to kind of work away from that in method 1. Method 2 uses that method, all right? But we're going to work away from that one. So all we're going to do, and we're allowed to do this because there is a equal sign here now, okay, this is an equation, is I'm going to multiply both sides, okay, by y times y plus 1. And by doing so, what happens is I have to multiply all the terms on the left side, on the right side, okay, I only got that 1 there, so 1 times anything is just itself. And so what happens is when you multiply this term right here, let me circle it, by what I have up here, what happens is you end up canceling the y plus 1s. Right? Again, when you're multiplying, okay, across, right, this I'm multiplying just y times y plus 1, okay, so what happens here is these things cancel. On this side, the y's cancel, and over here we're just left with what we have here, okay, so what happens is we get y times y minus, well, 1 times y plus 1 is just y plus 1. And on the other side, we get y times y plus 1. And once we are this far here, okay, we're just going to, combine like terms. I'm going to distribute this negative sign. All right, I'm going to try to combine like terms, so I subtract the y squared. I'm going to add the y. So y plus y is 2y, and then to get y by itself, I divide both sides by 2, and I get negative 1/2 is equal to y. Whoops. Okay? And so there's our final answer, right? And so what happens here, or if you wanted to check this theory out, is you could plug in negative 1/2, and for y, and what you would see is that this side right here all equals 1. Okay, so what we did was we just found the value that makes this statement true. That's all it is when we're solving equations. It's what value makes something true, right? If we had 3x is equal to 9, all right? Well, what makes this statement true? Well, x has to be 3, right? In this case, we found that y has to be negative 1/2, right, in order for this equation to be true. And this is the fraction buster method, okay? So I'm going to do example 2, and this will be the denominator job. So let me put method 2 here. All right, and maybe you might like this method better. Okay, so going back to what we were doing in the last lesson, we were trying to just add expressions, right? We didn't have an equal sign here, okay? Well, we needed a common denominator. And so let's come up with that common denominator. All right, now, to make things simpler, all right, maybe you guys won't like this. Oops, let me get this thing out of the way here. Okay, so, all right, in order to kind of make things simpler, what we can do is instead of having this 1/10 here, let's multiply both sides by 10. Okay, let's get rid of that 10. Let's get it out of there. All right, it's kind of bugging me. So what happens when you multiply both sides by 10? This guy goes away on the right, and on the left, you have to make sure that we multiply this 10 into both pieces. Okay, so we get now remember this is 10 over 1, right? So we're multiplying by here, so we multiply everything in the top. Okay, we're just multiplying the 3 and the 4. All right, so we got 30 over x minus 2 minus 40 over x plus 1 is all equal to 1. Okay, and the reason why I did that is because now when I come up with a common denominator, all right, I don't have to account for that 10 anymore. Because beforehand, what I would have to have looked like, it would have been 10 times x minus 2 times x plus 1. Okay, that's way too many terms, or way too many factors. Okay, so in order to kind of make it look a little lighter, all right, I multiplied both sides by 10. Now our common denominator, okay, that we're going to have to use, I don't want an equal sign. Well, yeah, common denominator is just going to have to be x minus 2 times x plus 1. Okay, it's our only option. All right, remember, like I said, when in doubt, just multiply those two denominators. Okay, so this side over here, I'm going to multiply the top and the bottom by x plus 1. And over here, I'll multiply the top and the bottom by x minus 2. Okay, and on this side, okay, in order to get that common denominator down here, right, I got to multiply the top and the bottom by both x minus 2 and x plus 1, right? Because what you do to the bottom, whoops, you have to do to the top. Okay, and in this case, in the 1, I had to multiply both the top and the bottom by x plus 1, x minus 2. Okay, so over here, I get 30 x plus 1 over x plus 1, x minus 2. Over on this side, I got 40 times x minus 2 over x plus 1, x minus 2, all equal to x minus 2 times x plus 1 over x minus 2 times x plus 1. Remember, this is just still the number 1 here, right? Those things all cancel out, okay? So now, what's cool about this method, and why I call it the denominator drop, right, is because once we have 3 common denominators, right, and we got everything kind of straightened out in the numerators, right, we multiplied by, 1 for each of these cases. Now we just drop the denominators, okay? Because if you think about it, when we would combine these two things, right, on the bottom, you would have on the equal sign, okay, x minus 2, x plus 1 is equal to x minus 2, x plus 1, okay? So in our minds here, and mathematically speaking, everything in the bottom has been equaled out, okay? So what we can do, right, don't worry about the mechanics behind it if you just don't want to hear about it, right? Just drop the denominator. Once everything is set up and we got everything in the right place, we drop the denominator, and now I'm just left with 30 times x plus 1 minus 40 times x minus 2 is equal to x minus 2 x plus 1. Okay, so once everything's been equaled out, and if we wanted to, we could add all these pieces on the left and right, or on the left, we drop the denominator. Now, all right, I'm going to distribute these two things. So it's a 30x plus 30 minus 40x plus, whoa, forgot the x, plus 80 is equal to, and when I multiply this thing out here, I get x squared plus 1x minus 2x minus 2. I'm going to combine like terms on the left, so I get a negative 10x plus 110 is equal to x squared minus 1x, or just an x, minus 2. I'm going to bring everything on the left to the other side. Cancels over here. And so what I'm left with on the left is 0. And then over here I got x squared. I'm going to add 10x. I'm going to subtract 110. So I get a plus 9x minus 112. Okay? Now you're thinking, oh God, is that factorable? Yes, it is. Okay? Remember how to solve quadratics. Okay? You had to get everything on the other side, set it equal to 0, and then you either had to use the quadratic formula, you can use completing the square, okay? You can use, well, in this case, this one's a factorable problem, right? So if you don't like factoring and you get to this part right here and you say, the heck with factoring, use a quadratic formula. I'm not going to write it down here. That's something that you could look up. But you can use the quadratic formula here to solve this problem. You don't have to factor, right? It doesn't say factor this problem. It just says find the value of x, right? Which is what we're doing. So I'm going to skip the shortcuts here. Okay, I know a little trick. If you guys want to know a little trick on your calculator in order to get all the values for such a large number here, ask me in class next time you see me. All right, so our factors here for negative 112, I'm not going to list them all, but the one I'm looking for is a 7 and a negative 16. Okay, add those two things up and you get a positive 9. Whoops, not with those numbers. There we get a positive 9. Okay, so our factors here are x minus 7, x plus 16. And in order to solve this, once we have it factored, all right, you set it both factors equal to 0, both expressions. And then you just solve for x. So x is equal to positive 7 here. X is equal to a negative 16 here. Okay, so we're actually getting 2 answers for this problem. I'm not going to take the time to put this into the values of x there, but you can get 2 answers for these. Okay, so just keep that in mind. Now also keep that in mind that sometimes you might not get any answers. You're probably thinking, oh my gosh. It's not that bad. It's just something you just have to recognize when you're dealing with rational expressions, okay? Because you have to check the denominator and make sure that whatever answer you get, okay, if I plugged it in for either value of x, do I get a 0 in the bottom? Okay, so if you look over here on the left, okay, I plug in negative 1/2 in for both of those y's, I don't get a 0 on the bottom. Okay, so keep that in mind when you're solving these problems. You have to make sure that we're not getting an undefined answer. So hint, hint. Keep your eyes open, all right? Especially on this problem. So I'm gonna go back to method 1 again. Okay, the fraction buster. All right, so if you don't like this method, you can use the denominator drop. Hopefully that last example gave you a good idea of what I'm talking about. Okay, so in this problem right here, all right, what I'm going to do is I'm not going to factor the top. Okay, I'm not worried about factoring the top. I'm going to factor the bottom down here, because when we're dealing with fractions, it doesn't matter what the numerator is, as long as the denominator is equal, right, when we're adding and subtracting these. Now, we could do something pretty gross here, and we could cross multiply. I strongly encourage against that, okay? That is a lot more work than you need. Also, you would get an x cubed in there. You don't want to do anything like that. So we're going to use method 1. We're going to come up with our fraction buster, which means we take a look at both denominators and we say, if we were to add all these things, what would be our common denominator? And so the only thing that we would be left to do, whoops, plus, right? So if I were trying to add these two fractions here, okay, I would need a common denominator of x plus 2, x minus 2. Okay? Now, if you look on the left side, we already have that. Okay? So we really only have to multiply the right side by our fraction buster, which is x plus 2, x minus 2. Okay? But I'm sorry. I'm doing method 1, my bad. So I want to do it to both sides. I'm sorry, I apologize, okay? I'm multiplying both sides, okay, by our fraction buster. So on the left side, okay, what happens is all these things cancel. These two things cancel. And what we are left with is 3x plus 6 is equal to x plus 1, x, x plus 2, sorry. Okay, now I'm going to multiply these things out. So I get 3x plus 6 is equal to x squared plus 3x plus 2. All right, now I'm going to bring over this 3x and this 6 minus 3x minus 6. So these cancel out over here. It actually cancels over here on this side too. And so what I'm left with is 0 is equal to x squared minus 4. Okay, now we should recognize this by now. This is a dots problem. So if we were trying to factor this, it would be x plus 2, x minus 2. Set both of those things equal to 0. And we get x is equal to a positive 2, x is equal to a negative 2. All right? Now, we're thinking, okay, those look like the right answer, right? So let's go try, if we put in a negative 2 right here, right? Well, negative 2 times negative 2, right? Negative 2 squared. Well, that becomes positive. And what's 4 minus 4? 4 minus 4 is equal to 0. So we can't use positive 2 on this side because that makes this expression over here undefined. And then on this side, if we try to use a positive 2, or if we use a any of the 2's really, a negative 2 will work, but if we use a positive 2 here, again, we're getting a 0 on this side, and we're also getting a 0 on this side as well. So, therefore, these two answers are no good. And so, this expression, there is no solution. And that can happen. Okay? That can very well happen. You have to check your denominator and make sure whatever solution you come up with, in this case we got 2 again, okay, but neither one of them work for x, because when we plug them in for x, we get a 0 in the denominator, and this is a math no-no, right? In the sense of it's undefined, okay? You can't divide anything by 0. All right, that was method 1. Let's finish up with method 2 on example 4. So I'm going to use method 2, which is the denominator dropper. All right, and so let's get started. So in this case, all right, if I was trying to add these two fractions here, right, if there was a plus sign here instead of an equal sign, right, the only denominator that would work would be 2x plus 7 times x minus 1. Okay, so what that means is I'm going to have to get both of those. I have to use both of those for my denominator on both sides of the equal sign. So we get 2x plus 7 here, x minus 1. And in this case, I had to multiply this side by x minus 1. Okay, so we get x times x minus 1. And over on this side, on the other side of the equal sign, you get x minus 5 times 2x plus 7. Okay, and we add x minus 1, 2x plus 7. Okay, and so now we have the same denominator on either side. Okay, these two things are equal to each other, right? And if I set 2x plus 7 times x minus 1 is equal to 2x plus 7 times x minus 1. Okay, no matter what value you put in for x, you're going to be equal. So we don't have to worry about making sure that statement is true on the bottom, because it is. The only thing that's not true is we don't know what value of x will make the tops true, right? So we're left with dropping the denominator. So I'm going to drop these bad boys, so get rid of them, and I'm left with x times x minus 1 is equal to x minus 5 times 2x plus 7. All right, finally, let's distribute. So I get x squared minus x is equal to, so I start out with 2x squared plus 7x minus 10x minus 35. Okay, so I'm going to bring this x squared over. I'm going to add this x. So I subtract x squared, add x. Okay, so I'm left with a 0 on the left. I get x squared. All right, so 7x plus 1x gives me 8x. And 8x minus 10x is a negative 2x minus 35. I know this thing is factorable. Okay, negative 35, a couple factors of 35. Well, the only ones I can think off the top of my head are 5 and 7. One of them has to be negative. So because it's a negative 2, we're going to use this setup right here. So we're going to go 0 is equal to x plus 5, x minus 7. Set both of these guys equal to 0. And we get x is equal to negative 5. X is equal to positive 7. Go back up and check. And it appears to me, if I put both of those things in for x, only in the denominators now, okay? Doesn't matter if you get 0 in the numerator. 0 divided by 5 is still 0. I can give out nothing. I can say, here's nothing, here's nothing, here's nothing. You can give out nothing as many times as you want, but you cannot divide by 0. But it looks like, in this case here, okay, you can put a negative 5 for an x, you're still good. Put a positive 7 in there for x, you're still good. And so these solutions are A-okay. All right, good luck, you guys. Hopefully that didn't take too long. It probably did, but these are some beastly problems, okay? So for homework, I want you to try all of them. Okay? Try them all right? And if you don't understand what we're doing, bring in the questions to class. All right, you guys.